Okay, in this video we're going to take a look at an introduction to derivatives, part B. So we're going to finish up the definition of derivative and how to find it. But what I want to do first is I want to review a little baby bit. So remember that common sense definition of what a derivative is, it's simply the slope of a tangent line to a curve at a point. For limits and for derivatives, so let me go ahead and write derivatives for you. We both have three different approaches to solve them, and basically the first one is numerical approach. That's using a table. The second one is graphical approach for limits and derivatives. That's drawing a graph by hand or using technology and then finding the slope of a tangent line to a curve. Then we have the final one that everyone loves, the analytic approach. That's using algebra or calculus. So I'm just going to scroll on down and I'm going to get to this one. Now this is going to take us a little while to develop, but I think it's a very powerful tool to see where it comes from. So our goal here is to find the definition of a derivative by hand. So basically we're going to be able to regenerate this whole formula in a matter of minutes, hopefully. So let's scroll down. Alright, so I cleaned up my lines here. My other lines in the first video were kind of sketchy. So basically this is what's happening. I have a green, so let me grab my green, tangent line to the curve at a point. I'm calling that point X. And then my goal is, and I have another red line by the way, that goes through X and it goes through X plus delta X. And we'll go over what delta X means in a second. And because this line goes through 2 points, this is called a secant line. So my goal is to try to get that red line to become the green line. So I'll say it again. My goal is to try to get that red line to become that green line. And if I can do that, I can figure out what the slope of a tangent line to a curve at the point X is. So let's go over some just basic vocab. Okay, so basically delta X, all that means is a small change. And delta X is this distance right here. So from X to X plus delta X, that distance is just delta X, a small change. Now we need to do a little bit more labeling before we can actually be successful here. So let me go ahead and let me label this order pair right here. We know that our function is called f of x. Yes, I gave you x squared, but for the actual developing of the formula, we're not going to use x squared. Alright, so the order pair here would be x comma f of x, and that's this location right here. The order pair right here would be x plus delta x comma f of x plus delta x. Okay, so in Algebra 1 and Algebra 2, we know how to find the slope of a tangent line. We said that the slope was equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We called this in calculus the average rate of change. And to find the average rate of change here, we have enough information. We can basically use the order pairs that I just wrote out for you to come up with the slope. So let me go ahead and do that. So this would be, and let me grab another color here, this would be x sub 1, y sub 1, this would be x sub 2, y sub 2, and let's go ahead and plug it in. You get f of x plus delta x minus f of x, which is your y sub 1, all over x plus delta x minus x. So that is the average rate of change, but that's not the green line. The green line has a slope as well. Now that's the red line slope. So let me put m, and then I'll put a little r for red line. So our goal is to create or to push this red line to become the green line, and we need a limit to do that. So what's going to happen here is this. If I write the limit as delta x approaches 0, that means that this distance right here is going to approach 0. Well, if that distance approaches 0, what you're going to find happening is I get closer and closer and closer to x. And then this line goes down, 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 and it forces the line to become the green tangent line. It's amazing. So what the limit does is it forces delta x, that small change, to be 0. So then my secant line becomes my tangent line. It's great mathematics. So let me go ahead now and do this. So we know the slope here for the red line was basically f of x plus delta x minus f of x all over. And in this case, I can cancel the x's out because it's an x and a negative x. So if I combine like terms, I just get delta x. So guess what? You just basically proved the definition of a derivative. So if you scroll down here, that's identical. And look here, I've got the notation f prime of x. That means first derivative. You just proved that with a tangent line and a secant line, and a little bit of calculus, the actual formula. That's pretty huge. So here it is. I would practice a couple times the actual proof, and I would also practice the actual formula a couple times. I'd write it out. F prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Yeah, I would write it out a little bit so you have it in your long-term memory, but now you can create it from scratch. Alright, let's scroll up and see if we hit our learning goal here. Students will be able to know what the derivative is. Hopefully you do. It's a slope of a line tangent to a curve at a point. And how many ways to solve it? There are 3 ways. Analytic, we have graphical, and then we have numerical. And we took it a step further. We even proved the definition of a derivative today. Alright, I'll see you in the next video. Thanks.